Hello folks, this is Tom from anti-proton.com, and you want to buy one of these, a Geiger counter, right? But you're not sure what to buy. I get emailed this all the time by people, what to buy, it's expensive, what should I get, some do alpha, some don't. Let me try to give you a quick little bit of information with this what to buy tutorial, okay? Just a quick little tutorial. I'm an enthusiast, an amateur, I'm not a physicist. Don't claim to be one. I'm not a professional. I'm just somebody who likes Geiger counters and other radiation detection equipment, and I'm going to try to help you with it. And I have a glove on for a reason. I'll explain in a minute. Okay, so for starters, let me tell you a little bit about a Geiger counter and how it works, and then I'll show you some and which one to buy. Make it nice and quick. I'm not going to go into details of how they work because I've already done that in other videos. I can do it in other videos and show you. That's not the point of this. Let me grab the thing here. Okay. This is a Geiger-Müller tube. Let me look down at my screen here and see whether or not you're able to see this thing up close. There it is. See that thing? This is a hollow tube. And this hollow tube contains gas and a little electrode right down the middle. There's a power that wants on one part of it that wants to go to another part of it, and when a particle flies through the middle, it sort of bridges the connection. And it's kind of a simplistic explanation of how it works. Actually uses electron discharge, but close enough. Anyway, all Geiger counters must contain a Geiger-Müller tube like this. If it doesn't contain a Geiger-Müller tube, it's not a Geiger counter. It doesn't have to look like this. They look different. Like this is a Geiger tube as well. This little thing up at the top. They can look different, but they all have to have the Geiger-Müller tube. If they don't have it, not a Geiger counter. So that's simple enough. Here's another Geiger counter with a different tube. It actually looks like the first one, but a lot shorter and a little bit thicker. Okay, all Geiger counters are sensitive to 3 types of radiation. Most, 90+%, are sensitive to one additional type, and some are sensitive to the 5th type. There's 5 types of radiation they can detect. Let me tell you what they are. Gamma rays and X-rays. They're basically high-energy photons. They go through everything. A gamma ray source, for example, like cesium-137 produces beta radiation, but it also produces gamma radiation, sort of. And gamma radiation, to give you an idea, it goes through everything. Like an X-ray machine at the doctor, it goes right through everything. That's X-rays. All Geiger counters can see gamma. All Geiger counters can see X-rays. They don't see them very well because they go through so easily, they often go right through the tube without being detected. But they can see them. Those are the first 2. The third type of radiation that's seen is called muon radiation. Muons come from space, and they're the result of high energy particle interactions in our atmosphere. They come down and slam into the ground at high speed. Sometimes they break apart, producing other types of particles called spallation, and you pick up all of that stuff. So muon particles are another type, and that's what gives you a lot of the background that you're seeing. A lot of the background that the Geiger counter sees comes from that. They should be able to pick up proton radiation too, by the way, but that's just a side thing. That you don't usually get a lot of that. So X-rays, gamma rays, muons. Most of them can detect beta radiation. Now you might say, well, what determines whether it can or can't do it? Like, is it a different gas or something? No, it's not. The tube can pick up everything. It's just the shielding around the tube that determines. Like if it has a heavy metal shielding around it, that'll block the beta, so you aren't going to pick up beta radiation. The tube could do it if it were just naked by itself, but it can't. It's blocked. So it's the shielding that does that. And you want shielding sometimes. Depends. Some people just want to pick up gamma. Some people don't. The last type of radiation is alpha radiation. And alpha radiation is picked up by tubes that have this, a window detector. See this window right here? Let me get this thing closer to your screen so you can see. See that? That grill, that's a metallic grill. Behind that grill is an incredibly thin sheet of mica that alpha can pass through. Okay? A tube that's thicker cannot see that. Most tubes actually, a lot of tubes are blind to alpha radiation. This little guy can see alpha too. If you look right here, you notice it has that little tiny window. See? You see the window, then you know you can pick up alpha. Why do you care about alpha? Well, granite countertops produce alpha radiation. Polonium-210, well, you're not going to worry so much about that, but I have a polonium-210 sample I was going to show you, but it occurs to me you're not really going to bump into that too often. Let's see what does. Thought I had some samples sitting around here. But a lot of naturally occurring radioactive material produces alpha. Thorium, uranium, both produce alpha radiation. If you're going to do contamination monitoring, if you're checking granite countertops, any of that sort of stuff, you want to probably be able to detect alpha. It's very useful. If you're just doing monitoring of background radiation, if you're doing, you're just testing your rock collection or something, you might not need to spend the extra money for it. I recommend it. I think you'll get a lot more out of it, but it's up to you. It's not a must, and everything that produces alpha, for the most part, is going to produce some gamma too. Not always, but for the most part. And so you can still usually pick it up, just not as well. Let's go to the Geiger counters now and see an example of this. Okay, let me get my Geiger counters laid out here. Let me get my camera and move my camera into position. I don't really want to edit this video, so I'm doing it all in one shot. Now, let's put the Geiger-Müller tube back together again. By the way, we're going to fit this guy back into its housing. And then we're going to put this there we go. By the way, this probe right here, you notice that's thick and metallic, blocking beta radiation, but you can open it up to see beta radiation. The probe is exposed and more easily damaged, so you would shield it if you wanted to later on. Okay, let me connect this back to the Geiger counter it goes to, and start that Geiger counter back up. And let's look at some sources and see what I mean. These are polonium-210 discs. They contain, well, polonium-210. Let's get a nice fresh one. Okay. According to NRC rules, ironically, I can have both of these, but I can't use them both together. Isn't that stupid? That's the rules. Rules are rules. And as you know me, I always follow the NRC rules. Why? Because then I don't have to worry about a bunch of crap from them later on. Trust me, I've already called them on the phone and asked them for clarification on their rules so many times, they probably blocked my number by now. All right. Let's turn the sound on. And you notice alpha. But if you move a few inches away, you detect nothing. Cut the sound off. The sound's on in this one. Again, it's got to be right on it to detect it. But this guy does not detect it. Don't hear a thing, do you? It's not ticking at all. It's blind alpha particles. Now, there is a fruit fly flying around in my video. Isn't that great? Well, say hi to the fruit fly. I eat a lot of fruit, so fruit flies tend to pop out. And you have to kill them. It's obnoxious when they get out. I think fruit flies are born pregnant. Like they bump into a wall and then, like, you know, they just split into a couple. That's how I look at it. All right, here's a piece of granite countertop. To give you an example. Not much, but a little bit. See how you can pick up something off your granite countertop? And that'll tell you if it's radioactive or not. This thing's still pegged out from the polonium. Let's cut the sound off. And then let's take this guy and see what it can do. Let me put this to where you can see it. I don't know if you can see that or not. And let's zoom in. Okay. Not getting much. So you see, this kind of detector can't detect things like that. It's missing all that alpha radiation. There is some gamma, but there's not enough to really make this thing do too much. And then a little detector like this can detect it. It can detect alpha, but its alpha window is so small that it's barely picking up anything. So what you're learning probably already from looking at this is that this type of detector, the type of this big wide thing right here, this big wide pancake, is incredibly useful. It's the most desirable type of Geiger counter. And the reason is that it's ridiculously sensitive. When you think about it, sensitivity is the most important aspect of the Geiger counter. Now, if you're taking something else like, for example, cesium-137, you'll notice a slightly different result. All of them are sensitive to cesium-137. But notice how this little guy right here is a very small tube, and it's only barely picking it up. This one can pick up the cesium-137 through the other Geiger counter. Here, you go away. Notice the difference in sensitivity? And that means you can pick stuff up better. This guy can pick up the cesium-137 as well. It's only picking up gamma right now. If we open up the beta shield, then we're hard over. You can adjust it to a different range and pick it up. So the point of the matter we're getting here is that each one of these things has different sensitivities. Now, let's talk about what to buy and why. All right. For starters, most people are going for cheap. Let's all admit it. I'll talk about some expensive ones, but everybody's usually going for cheap. Why? Because our economy's toast. So that explains that. All right. You can find cheap detectors that can range from prices of 100, maybe 200, and they're going to be like this or less. They're going to have very small detectors on them. There's nothing wrong with these, but you've got to understand they're not very sensitive. See what I mean? This is 3.7 kilobecquerels of cesium-137, and it's sitting right here, and you're not getting anything. So as you can see, not all Geiger counters are the most sensitive out there. It depends on how big the tube is. The size really matters. And this thing has a tiny, tiny tube about that big, right? Little tiny tube. See? You put it right up against the window, it's sensitive, but it's got to get against the window. What you want is a unit like this. Oops, with the sound on. Much more sensitive. If you buy one of these little guys, you will be perfectly happy with it, but you need to just be aware of the sensitivity issue. This is not for detecting a very, very slight contamination. This is for detecting larger contamination or having a uranium sampled or something to play with. You need an actual reasonably strong source to pick up with one of these little guys. Okay? I would recommend, if you're going to get one like this, a small one, they're very useful. They're very, very portable. They're easy to use. I would recommend the Maser Systems PRM 8000. I'll have a link to it in the information page. It looks about like this guy right here in size, but it has data logging, which means it can log actual data that goes into it, and it keeps a memory that you can then retrieve of what happened and at what time you saw what. Very, very useful little device. It shows in different readings and stuff on the screens. Very, very nice. I would recommend that. This is a CRM 100 from International Medcom. There's another unit called a Rattler 100 that's almost identical, and there's nothing wrong with this unit, but for the price, I would go for the Maser Systems. I didn't have that available to me at the time when I bought this, so I got this. There's nothing wrong with it. It's a perfectly good unit, but I'd go for the Maser Systems instead. Okay. Also, there's some inexpensive kit units you can buy and make yourself. I do not have any skill at making that stuff, so I don't buy those. And you can also get some from Atomic Dave, who sells some really, really good little units. Next up on the list for inexpensive is going to be these guys. The famous CVV 700. This one has a sounder put on the side. This sounder here can come off. Here's what you need to know about the CDV 700. First off, only buy the CDV 700. Do not buy a 715. Do not buy a 717. Do not buy a 720. Do not buy a 7 anything. That is into 700. This is the 700. This is what the 700 looks like. The one that has the handle that's like all yellow and doesn't have a tube coming off of it, don't buy that one. Only buy this type. And there's several different types. There's Victorines, there's Antons, there's Lionels. They're all good, but you want the 700, and you want either a 706A or a 6B. That's the subtype. Now, here's some things to know about these. Read the details. You're going to see these on like eBay for the most part. Read the details. It'll say, in great aesthetic condition. That means it looks good. They'll say, appears to be operational. That means it turns on and they haven't the slightest idea whether it's accurate or not. All right, keep that in mind. What you need is a unit that's been calibrated. Like this guy is calibrated. See the calibration sticker? This calibration sticker right here tells you exactly, well, it tells you this unit's been tested to make sure it actually works correctly by Geoelectronics in this case. When I bought this unit, it came calibrated as well. To know if the unit is calibrated when you get it, get the unit, and you'll see you have a ×1, ×10, ×100 on the scale. Set it to the ×10 position. Now, see the check source on the side? Don't buy one that doesn't have a check source. If the check source has been removed, don't get it. You want that check source, and here's why. Open this guy up, put it against the check source, put the middle bar right here against the check source. See? And see if this hits about 2.5 milliroentgens per hour. Actually, it's not milliroentgens, it's millirems. Let me see if I got that right in there. There it is. It hits about 2 to 2.5, somewhere in there. You might have to get it just right. Then it's calibrated right. Come on. I don't think I'm holding this on right, because it's usually more correct than this. Well, anyway, I'll figure it out. I'm not holding it on there right, but if it gets around 2 to 2.5, then it's correct. If it's not, you need to either recalibrate it or return it. These are reasonably easy to repair. You can open them right up. How does this thing come off? I don't remember how it comes up. Well, anyhow, this comes right off. If I can remember how to do it. Oh, bloody hell. I can't recall how to take that off. But this opens up and comes right off, and you can get inside and repair these things. Now, the machinery that's inside of these things is analog circuitry, like an old television. If you could repair an old television, you can repair this. And that's an important thing to know, because when you buy it, it might need repairs immediately, because a lot of these have been in service since the 1960s. So when you see these things, be very careful buying them and know that you either know how to fix them or that you know how to find somebody who can fix one of them. Because there's a price to be paid if you have one of these. These things are rugged, they're good quality, they can do all kinds of stuff. But keep that in mind. Another thing is they do not come with a sounder by default, usually. And they only have a headphones jack right here. And you'll want to either buy something that screws on here that produces sound, or you will want to hook up headphones to them or whatever, and you'll need a jack. And there's a couple websites out there that sell good stuff for this, and I'll see if I can list one on my details page. Okay, so next down the list, you get into it's the more expensive units, 500 and up. That would be like this guy. There's two famous types. There's the inspector that looks like this, except that this detector, same exact detector, is built into the bottom of it. See, this is where that detector would go, but it's not going there because this is the Inspector EXP Plus. This is the unit that has the probe. The Inspector by itself is about 500 bucks. The EXP Plus is about 750. You can buy a Maser Systems PRM 9000, which looks about like this, more or less. Has the same exact probe in it. It's not close, it's the exact same probe, but it has data logging features and some other nice stuff, which makes it probably even a better deal. I don't know. I love my SE International, and I'm not sure I want to say anything bad about them. The PRM 9000 looks really great, though. It really does. These guys are really good too. I love my Inspector. The probe is nice, but I find the probe makes this thing not very portable because it's like the probe's kind of bulky. So sometimes I wish I just bought a regular Inspector. Just keep that in mind before you buy one. And if you do buy an Inspector and not the PRM, make sure you get this rubber housing, because this thing right here looks like this. But you can buy this rubber housing for it that goes around it. And it really, really has protected this thing like a million times. Saved me a bunch of time and money. Okay. Next up on the list, if you're going to spend even more, if you're going to go over 700, what I would recommend is that you go for a Ludlam. Now, I don't have a Ludlam to show you, nor do I have a picture of one. So I'll put a link in my description that you can go look to. Look at my description of my details, and you'll see the link to Ludlam. The Ludlam Model 3 Geiger counter with a 44-9 Geiger tube thing on it It is absolutely to die for. It is hard metal. The thing could probably stop a bullet. It will last for like all of eternity. It is really great. You can hook every probe you can imagine up to it, including scintillation probes if you ever want to get into that. But they're expensive. They're not cheap. So keep that in mind. I would recommend that if you're just a hobbyist and you have any electrical skills, to get something like this guy right here. They can be under $100. They're usually under $300. Beautiful, beautiful unit. If you go to geigercounters.com, you can get a replacement unit that's the same as this for this. Yeah, that's right. For 250 more bucks. So you buy one of these things for like $100, fix it up yourself to work in good condition, then buy for about 250 bucks a replacement like this that fits right here, and you have a beastie device. You have an ultimate Geiger counter. You can go for one of these or a Maser Systems if you like. And if you're going for cheap, because you have just a tiny little bit of money, you can buy like a Maser Systems 8000 or an Atomic Dave or even a Geiger counter kit. So that's what I'd recommend. If that helps you, I don't know. If it doesn't, let me know. But be careful of one thing. Be careful of things that claim to be Geiger counters that are not. For example, electromagnetic readers. Do not buy those things. I mean, buy them if you need an electromagnetic reader, but don't buy them as a Geiger counter. I see them come up all the time on searches. They are not Geiger counters. And most of all, do not buy these things unless you've looked them through very carefully. Do not buy CDV 715s. Do not buy these things if they say they're in maybe okay functioning order. They're not 100% sure. And if you don't know how to do anything with electronics, just keep that in mind, because you don't want to get stuck with something you can't use. That's no fun. And always make sure your Geiger counter is calibrated and up to date. I'd recommend buying a check source from Spectrum Techniques, $50, and you can test this thing and you'll know exactly if your unit's up to date or not and if it's working. Take it, put it somewhere, put your Geiger counter on it, write down the reading you get every 6 months, put the Geiger counter for the same amount of time in the same area and write down the reading again, see if it changes. That's how you determine if the thing's operational or not. So, I probably didn't need this glove, I just put it on for formality's sake. This has been Tom from anti-proton.com. Maybe this will help you as a little bit of a buyer's guide. Maybe it won't. Ask me if you have any specific questions. I'll be happy to answer them for you. But remember, it's up to you when you buy a Geiger counter, and nobody can help you on that but yourself. We can all, well, nobody can tell you what to buy but you. I can only give you advice. And look at my details section. I have lots and lots and lots of links. This has been Tom from anti-proton.com, and bye-bye.